everyone, my name is Lily, and I'm a software developer. And every now and then, to keep things interesting and expand my knowledge base, I take up a new hobby. 3 years ago, yesterday, that was crochet. One weekend I just sat there with the wrong type of hook and the wrong type of yarn, I had no idea what I was doing, just in front of a YouTube video, pausing, rewinding, repeating the movements of the hands on the screen. And so I guess by now it kind of also makes me a software developer. And brace yourselves for more terrible puns. So as I was getting hooked on making little crocheted flower after little crocheted flower, I realized I was basically doing a computer's job, passing instructions at runtime. This made me think that crochet and other yarn crafts more broadly were maybe a form of programming hidden in plain sight. And so, as you probably have guessed by now, this talk is about actual yarn, not Facebook yarn, the package manager, which also has its merits, I'm sure, but I prefer the fluffy kind. Look at that, how satisfying is that? I've got an little finish because it's brilliant. So fluffy. It's wasting a lot of thread, but it's so fluffy. So I'm going to be talking mostly about crochet, because this is what I know, but it also could apply to other yarn crafts. And also it seems that crochet is down with the cool kids these days, at least according to Google Trends. So the red line is crochet going up, and knitting is slightly decreasing in interest. So the first similarity we can see between developer and crocheter is the community, brought to you by the power of the internet. If I want to learn about a new framework, I look for a blog, a forum, a screencast, Stack Overflow. And if I want to learn new crochet techniques, I can do the same, although granted, maybe not on Stack Overflow. Before crochet terms became more common in the middle of the 20th century, the books of patterns you could find were of actual samples that you could study and reproduce. And to me, that feels surprisingly like Stack Overflow, CodePen, or GIST. And if we look at the history of crochet and computing in parallel, we can find more similarities, not only in the way of programming, but also in the behavior of their respective communities. Right. So similarities occur at the very root of computing and yarn crafts. There's often an argument, or well, let's say discussion, on whether software is science or in fact a craft. Both imply a competency, a skill from the operator, but in people's minds, really, tech equals science, because there are a lot of equations that needed to be solved to get to where we are today. Science instantly evokes knowledge, empirical data, whereas the word craft, coming from the Old English craft, evolved to mean something built or made. Well, I don't know about you, but I run frequent builds at work when I code. In software, we also thrive to refactor our code to find more elegant, more crafty solutions. And in crafting, there is the notion of transmission to an apprentice, or more widely, a community, that we find in software too. So it looks to me like we're indeed going to be comparing two crafts. This is Mademoiselle Éléonore Riego de la Branchardière, Mademoiselle Riego for short. Contrary to what her name might suggest, she actually lived in Ireland. We don't know much about this lady's background and origins, but she was a very influential figure in the 19th century world of yarn crafts, particularly lace and Irish crochet. She wrote dozens of pattern books, allegedly from a very young age. In my opinion, she was, and this is where it gets mildly controversial, a pioneer in open source crochet. Why not? Let me explain a little bit. As I said, she was very prolific in publishing pattern books, but at the time, this is the middle of the 19th century we're talking about, one couldn't write down patterns because there were no defined terms for the different stitches. So instead, what she published was a collection of samples of her own designs that people would easily study, reproduce, and amend, a bit like exploring the source code. And it is exactly the same process as going to CodePen or JS Fiddle and copy someone's code samples to repurpose them to your needs. And we often do that, I'm sure. So this evolved in the 20th century when yarn manufacturers paid designers to crochet samples of their design directly on the skein of yarn to be sold. So you'd buy it and continue the pattern straight away, just like forking a project and making your own adjustments to the source code. Speaking of which, the modern GitHub for crochet is Ravelry, and there are other platforms, but designers can post their patterns for other crafters to use, make, or test. And posting feedback or recommendations on a pattern is akin to opening an issue or a pull request on a project. Crochet and computer software have both evolved over time through innovation, natural selection, and their respective communities. And the evolution goes a bit like this. Borrow some code, modify it, test it, fix it, modify it, test it, repeat, and at some point in that cycle, share it, preferably when it's at least tested. This is Jacques de Vaucanson, Frenchman and clever cookie. For the backstory, he fooled a lot of folks in 1735, making them believe that a mechanical duck of his invention could replicate a real digestive system. In other words, later, he became a director of silk mills in France, and that's really where the interweaving starts. In 1745, he invented a punch card system for controlling weaving patterns. This inevitably helped the foundation of the jacquard loom in 1801, which in turn influenced the early history of computing, as you may know. This is Lady Ada Lovelace, which in the middle of the 19th century, I think it was around 1842, helped Charles Babbage in his endeavor to build the analytical engine, heavily inspired by the aforementioned jacquard loom and punch card system. Ada Lovelace was also one of the first computer programmers creating algorithms and patterns to be computed by this new machine when it would be finished. Just like Mademoiselle Riego created crochet patterns to be computed by humans. Now for a short interlude with a functioning Lego loom, because it's partially relevant what I was saying, and also it's Lego, and also I'll let you enjoy. Right, back to history. The analytical engine was purely dedicated to calculus, and that was just in theory, as it was never finished. Whereas Ada Lovelace saw beyond simple arithmetic and envisaged more complex tasks being performed. But in a way, a crocheter always counting stitches is an organic analytical engine, with the stitch as the instruction and the yarn being fed through the hook like data into a compiler. By now, I hope you can see some more parallels emerging between crochet and computing. If we stretch the thread a little, we could say that computer software and crochet software appeared around the same time, software being the programs and information used by a computer. And we've already established that there are human computers, so in theory, there's such thing as crochet software, right? Stretching a little more, we could affirm that crochet software is a form of self-replicating information that gets passed on from one crocheter to the next. The early recorded technique for crochet was so simple that they became automatic to perform. People would crochet whilst praying, traveling, talking. So there is a form of automation in both mechanical and human computers. In Ireland, crochet techniques evolved and spread at a time when men, women, and children had to adapt their skills to find new streams of revenue, and that happened partially through crochet. Similarly, today, we see a multiplication of code clubs or women in code initiatives spreading coding technique to one and all. In the mid-19th century, there was a reduced number of stitches compared to today. Their name didn't really matter as no instruction was written down, but we'll see an evolution in the programming language emerge later on. Right. So no matter how complex the crochet stitch, it always starts with one loop on the hook and ends with one. There is a pre-production stage in crocheting where you select your yarn type, your hook size, and check the tension as per instructions. In a way, it's like writing a small unit test where you end up assembling a few rows together and measuring the output to ensure it's the expected size. By 1950, the names of the basic stitches printed in the UK had been standardized. Yay! Universal programming language. Well, you see that coming? Not really. At the time, and even today, a high proportion of other English-speaking countries still use different names. So if you are unaware of the differences, your end result will be far from the expected one. By the way, this talk is in US crochet talks, unless specified otherwise. And when I say you can have surprises, fundamentally different stitches can share the same name in distinct languages. So UK double crochet is a US single crochet, and a US double crochet is a UK treble crochet, and so on. You get the gist. That's just for English-speaking countries, but other languages have their own terms too. So American English doesn't rule the world of crochet programming languages, but it's widely spread. Luckily, there's also a visual language, a master language, if you will, that's uniform across all spoken languages. And that's like your zeros and your ones, that you can translate it into your own local version. So if we look at a crochet pattern, for example, this one comes from Yarnspirations, which is another good platform for patterns. We can already see scalability in the various sizes, variables in the color changes, and loops and recursion. Stitches can be combined into a near infinite number of designs, just like the primitive elements of a programming language can be combined into any program. So if these crochet instructions were written in JavaScript, or any part of them, they probably look a bit like that. Feel free to refactor. Right, live demo. So, here I am, human computer, with a compiler in my hand, interpreting a pattern, if I can get the hook right, at runtime. Although I've prepared for today, it's safe to say that the whole pattern hasn't been loaded into memory, and I've got my model here. So I'll do a little square. Right. And as I come to change of color in the pattern, as it goes, I will have to deal with literal multithreading. I need to manage two different strands of yarn at the same time when I change them over. I might give that up. I didn't think that through. While crocheting, I can sometimes encounter race conditions as well. That can be if I run out of yarn before I'm done using it, or if my mind jumps ahead in the pattern and counting, and the hook doesn't follow. So crochet and programming even share the same language at times. Take blocking, for example. Thread blocking in software means your thread is suspended, and more often than not, your application will hang or crash even. And in yarn crafts, that means fixing the panels of a garment to the correct shape and size, so effectively preventing it from going further and being displaced. But if I make a mistake, what tool do I have for debugging? Well, the problem with crochet pattern is that you can't see the result until it's been fully compiled, and that can take weeks sometimes. But you can put breakpoints and step through your code, meaning that you can wait until the next round to check the alignment. And because it's just a big interwoven loop, crochet items are easy to unravel. So I don't create any waste of thread, just a waste of time for me, potentially. Right, moving on. Once you've finished compiling, there's a mandatory post-production stage, which is weaving the ends in. Design is still a beta if the ends haven't been dealt with. You can also choose to document your code with a README or wiki. Generally, that's your pattern. Or add comments to an existing one if you've improved on it, because how often do you really write code from scratch? Right? Now that we have the basic mechanics of Crochet down, let's make things interesting and look at how we can mix this analog medium with digital. There are many ways that people have been hacking Crochet through the years, diverting it from its primary purpose. Young crafters have been experimenting with cryptography, hiding secret codes and messages in their items from very early on, sometimes to denote belonging to a community or a particular social rank. More recently, Agent Coach and Yarns, which is a yarn shop, paid tribute to the human computers of Bletchley Park with a collection of knitting and crochet designs, such as this Morse code cardigan. And we could push the relationship between crochet and technology further and devise a computer vision program that would use a crocheted or knitted piece as a set of instruction, and that effectively will make it a punch card made of yarn and loop back to the origins of computing, right? Or to spruce up crochet, you can ditch regular yarn and use electroluminescent wire, like here. That's quite nice. I might make that for Christmas. And there are many other ways to bring together yarn and technology. Sometimes you can give the control back to the machines, either with a knitting machine or even a 3D printer, like here. This is a Japanese invention that prints little nests of yarn, and then you can sow little seeds into it and grow plants out of them. More recently, Google launched their Project Jacquard and have transformed woven fabric into a touch interface. But it's not really much fun if you leave the computers do all the work. Yarn crafting is, after all, a hobby. So in a more DIY fashion, you could see the same kind of interface with conductive thread being knitted or crocheted into garments. So, crochet makes a computer of the crocheter, but technology can also enhance your approach to crochet, a bit like an OS upgrade. There is this technique called corner-to-corner crochet, C2C for short, where, based on a grid design, you combine stitches into little pixels of yarn to reproduce the pattern. The difference with using regular grids is that instead of working in rows and columns, as shown here, you work in diagonals and alternate the direction for every other row. So you go one way, the other, one way, the other, and so on until you've compiled the whole thing. When I made my first pixel blanket, where are you? Sorry. The most tedious part was to stop and count tiny squares on a sheet of paper and cross out the ones that were done. It slowed me down massively, so I fixed it. I opened my favorite code editor, added D3.js so I could create and manipulate SVGs, and built myself a framework to create patterns. This is Quartet. It's ugly, but it works. As well as making patterns and estimating the amount of yarn I need, Quartet, with all sorts of array slicing, splicing, reversing, and sorting magic, reads them out to me, diagonally, alternately, and per group of color. So, for example, here I've got 15 squares of waterfall color to do. Now, that drastically reduced the number of mistakes I made and improved my speed. And in future iterations, I think I'll implement proper voice control so I can avoid stopping and pressing keys to get the next stitches. I'm also looking into wearables, and I think I could maybe detect the stitch completion with an accelerometer and automatically move on. Having voice reading out patterns could unlock access to crochet for a wider range of people. Just like software, crochet is also concerned with accessibility issues. This person, for example.
So you have a contraption that's been made for you.
Yes.
It was actually made for me by Mississauga Hospital. And when I had the stroke and I went to a rehab, and that's when they did it. And actually they did it with more with knitting needles in it. And at the time I could do plastic canvas that way. But I went home and I thought, okay, how can I do this with crochet? So I did, I finagled two elastic bands to put it in so it holds it steady. And I've done everything with it.
Wow, good for you. That's neat.
Yep.
There's a will, there's a way, right?
Yeah, exactly.
Right, so this person, for example, had to learn a different way of crocheting after suffering a stroke. And a lot of stroke sufferers learn one-handed crochet. And that's a solution that's probably inspired by the way of crocheting in the early 19th century, where at the time, in the 1820s, you would hold both your yarn and your hook in the same hand and just pass the yarn over with your forefinger. And it changed in the 1840s to the technique we know today with the hook and the yarn in separate hands. And accessibility in yarn craft has been a concern for a long time. Remember Mademoiselle Riego? She received a certificate of merit in 1871 for teaching to crochet to a blind lady who then went on to make items for the Pope. So as we've seen, crochet may encounter the same issues faced by software developers and tries to tackle them through innovation. I've explored with you the similarities and parallels of crochet and programming. And I think it's time for me to merge my branches back onto master and claim, and I hope you agree, that crochet is a programming language, which means that if you're a programmer, you can become a yarn crafter, and vice versa. To conclude, I'll say this. I believe there is a misconception nowadays that teaching kids to code will make them all software engineers. Well, it won't, because otherwise our generation will be out of jobs pretty quickly, right? But it will give them the basis for logical thinking and problem solving that can be applied anywhere or almost anywhere. So if you don't have access to enough computers or are worried about exposing them to screens for too long, well, just teach them to crochet. Thank you.
We still have some time for
We have
some
time,
Q&A,
then
so-
I'm happy for questions, yeah. Or not. Hi, Ben.
Right, okay. So you get like, sorry, I don't know if this is an actual question, but like, so the things that you had where you're like generating the flat patterns.
Yeah.
Are there any kind of like computational like 3D model generators out there, or is that not a thing?
Not that I know of.
Ah, okay. Cool. Sorry. Yeah.
Yes.
Is it
Oh, sorry.
software that you made available?
Not yet, because it's ugly. And yeah, it needs a lot of refactoring. I did that a few years ago when jQuery was still a thing, and I kind of need to refactor. Yes.
With the difference between the American and the British codes, I mean, can they be translated from one to the other?
Yes,
or is
so,
it more complex than just syntax?
That was a long time ago. Oh, no. Yes, so all the stitches have equivalents, but sometimes it's just really annoying that the same name is just not the same stitch.
So on the next slide, you have the
That one?
the one that.
Yep.
So there is only one kind of symbol kind of set. Is that
Yes,
what you're saying?
that's your master language,
Yeah.
and all people from all countries will know how to read this in their own local
That's
stitch.
quite amazing that there's only one standard of that.
Yeah.
That could have easily deviated more. Okay.
Yes.
How difficult is reverse engineering? Like if you have a piece and expanding it into like that kind of diagram?
It's fairly, so I've got I don't know the diagrams by heart, but so a double crochet is this. I know roughly from here that a double crochet will be that little chain here, so you could potentially go and look at a finished piece, but it probably will take forever.
Can you
Refactor
your crochet?
not without starting all over again.
Just like normal refactoring.
Okay,
Yeah. Good, thank you.
great. Cool.
And if you wanted to read the books I've read or the links I've read and have all the credits for the images, then this link will take you to doc.